Hello student, I am Professor Jayanta Chopre, working in Electronics and Telecommunication Department. I would like to welcome to this lecture of System Analysis. Now in previous lecture, we studied the convolution sum, and the convolution sum is used for the discrete signal. Now in this lecture, we are going to study the computation of the convolution integral using the graphical method for the CT signal, and in that we will study the convolution of the unit step function with unit step function. Second one is the unit step to exponential, then exponential to exponential, unit step to rectangular, and the last one is the rectangular to rectangular. Now we know that the convolution integral consists of the four steps. First one is substitute t equal to 0 right here, and if this t equal to 0, then we will fold that signal at t equal to 0, then shift it to the right by t, then take the product of x of tau into h of t minus tau, that shifted signal, and integrate over the intersection. Now these are the steps to evaluate the convolution integral, and we will use this step. Now instead of this tau, here in this equation we use this another dummy variable, that is lambda. We can use lambda or the tau dummy variable. Now if f of t convolve with g of t, we can write this as minus infinity to infinity f of lambda into g of t minus lambda d lambda, or the minus infinity to plus infinity g lambda f of t minus lambda d lambda. As we know that this convolution obeys the commutation property, which means the integral is evaluated in lambda domain or in tau domain. Now here the step for the convolution. Now first step is create a dummy variable, means replace this t by the dummy variable lambda or tau, and make each waveform a function of lambda or tau. Means this waveform is with respect to tau or with respect to lambda instead of t. Then second one is time invert one of the waveform. Right? Does not matter which, first or the second waveform. If invert x of tau or h of tau, any one waveform, or g of here tau, invert this g of minus tau or g of minus lambda, means here the second waveform is invert. Shift the inverted waveform by t. Right, we will shift this waveform along this axis, means along this lambda axis or along this tau axis. This allows the function travel along this lambda axis or tau axis. Then find the product of this converted, this waveform is in tau domain first, and second one is this is the inverted and shifted waveform. Take this product of these two. Then for given time t, integrate the product for the intersection of this lambda is greater than a and b, means the limit of integration becomes lower limit and this becomes upper limit. Means if this waveform is like this first waveform is like this is 0 to 2, and if the second waveform is intersect with this and this is 0 to 1, then the intersection of these two this will start from 0, means A is 0 here and B is 1. And combine all the integral after traveling the waveform for minus infinity to plus infinity. These are the 6 steps, and we will follow these 6 steps to find out the convolution integral. Now first we will consider the unit step to unit step, convolution of unit step to unit step. And here we have taken this example, right, that is u of t, h of t is u of t and x of t is 2 ut. Now what is the first step? Now this is the function in time, and this is 2 u of t, and our aim is we have to find out x of t, y of t, that equal to x of t convolve with h of t. Now then the meaning of this is minus infinity to plus infinity x of tau or lambda into h of t minus lambda, lambda or tau d tau. Now here we will consider the dummy variable tau. Then this second signal is, this is t and this is u of t. Here the magnitude is 2 and here the magnitude is 1, u of t. Then what is first step? Convert this in dummy variable axis. This is tau, this is tau, this is 2 u tau, and this is u tau. This is the first step, convert this. Then what is the second step? Fold any one signal, right? Fold any one signal. Now here we will fold this signal, this tau, this tau, and this is u of minus tau. Fold this signal. This is 1 and this signal remain as it is. This is 2 u tau. Then take the product of these two signals. Next step. Now if we take the product of two signal, then we will shift this signal, right? Now here this product is 0, hence we will shift this signal. Next one is shift this signal. Now this is the t tau tau, this is 2 u tau. Now if we take this product of these two signal, then we are getting this product is like this. This will start 0, means this signal will start from 0 to t, 0 to t. This is the product of 2 u tau and this is u of t minus tau, and the magnitude is here this 2 and here this is 1, means this magnitude becomes 2. Then we will integrate this, right? Last step is integrate from a to b. Now here a value is 0, means y of t, that equal to integration 0 to t to u of tau into u t minus tau d tau. Now magnitude is 1 and 2, and here this is 1, means this is 0 to t 2 into d tau. Now integrate this and substitute the limit, means this is t 2 tau t 0, means this equal to 2t. Hence what is y of t? Y of t, that equal to 2t. Means if we plot this t versus y of t, then we are getting this graph is like this. For 1 this value will be 2, for 2 this value will be 4, mean the slope of this line will be 2t. Then the second signal is, again here we will consider the convolution of the step signal with the step signal. Now what is the first step? First step is convert this signal into dummy variable, represent the signal into dummy variable, that is tau. This is u of tau. Now this signal will be like this, h of tau, and h of tau. Now this will start from 2, and this is shifted t minus 2. This is u tau minus 2. Then fold this any one signal. Now here we will fold this first signal, this tau, means this signal will start. If I substitute tau at t equal to 0, this will start from minus 2, and in this direction this is minus 2. This is u of this minus t minus tau minus 2, right? This is folded signal. Then shift this signal. Then we will shift this signal by the t unit, means here this is u of t minus tau, and we will shift this signal for any t. Now this become t minus 2. Now when the overlapping is occur, if this signal is, this should be below this value, 0 value. Means if the signal is like this is tau, this one is first signal u of tau, and this signal is shifted by t minus 2, the here like this, means this, and this t minus 2 is here. Then the overlapping will start from 0, because the first signal is exist from 0, and we will take this product of these two. This magnitude is 1, means product is 1, and the limit of integration, the overlapping is occur here, and the limit of integration is 0 to t minus 2, 1 into d tau. Means if we take the integration, that is we are getting this is t minus 2, and if we plot this graph, this is y of t is the answer, means this is the convolution for u of t, convolution of unit step function and unit step function. And this will start when t equal to 0, this is minus 2, and when t equal to 2, this is 0, and this will start from this. This is t, and this will be y of t. Similarly, you can find this, the convolution of this unit step signal and the unit step signal. Then next one is the computation of the convolution integral with the unit step to the exponential signal. Means first signal is the unit step signal, and second one is the exponential signal. Here we will take this example. The impulse response of the LTI system is h of t is ut, means this is the unit step function. Determine the output of the system if the input is this exponential signal for a is greater than 0. But here both signals are exist for t is greater than 0, greater than or equal to 0, because here this one is ut and this is ut, and we know that unit step signal is exist only for t equal to t is greater than or equal to 0. Now first we will draw the first signal. The first step is draw this signal x of t in dummy variable, right, tau, and that equal to, this is the exponential signal, e raised to minus a tau u of tau, and this will exist for this. Then this h of tau this is the h of tau, and again the magnitude is here 1 h of tau, right, representation of both signal in dummy variable. Then next one is fold this signal, any one signal. Now here we will fold this second signal tau, h of minus tau means take the mirror image of this, and the mirror image of this is h of minus tau, and this will be like this. This is 1. Then shift this signal, right, we will shift this signal along this tau, means as this is 0, means overlapping will start as the signal is exist from 0. Now we will find out the upper limit and the lower limit for this. This is e raised to minus a tau, and here if I shift this signal here, this is t tau, then the overlapping are like this. Instead of this, if I consider here, this one is t, then this over multiplication of these two signal, if we multiply this signal with this signal, then the multiplication of this signal will exist from this, and we are getting the signal e raised to minus a tau, and this signal h of t minus tau is this signal, and multiply this signal, right, and after multiplying this we are getting the signal is like this. This is exponential signal, and this will exist from, this is tau, from 0 to t. Hence the limit of integration becomes 0 to t, and the resultant signal is e raised to minus at. Hence we will integrate the signal y of t, that equal to, last step is the integration, right, this is e raised to minus a tau into 1, 0 to t, e raised to minus a tau into 1 d tau. Then take the integration e raised to minus a tau divided by minus a, 0 to t, this is minus 1 by a, e raised to minus a t minus e raised to 0, means y of t, that equal to 1 by a 1 minus e raised to minus a t. Now this is the convolution of the exponential signal with step signal. Then the convolution of exponential to exponential signal. Now here for this system, LTI system with the unit impulse response, mean this is the unit impulse response, ht equal to e raised to minus 2t ut, and second signal is e raised to minus t ut. Both signal is exist for t is greater than or equal to 0, and both signals are exponential signal. Now we will find out this convolution of these two signal. Now the first signal is this h of t. Now first represent this signal in which domain? In dummy variable, that is e raised to minus 2 tau. This is h of tau, and this is e raised to minus 2 tau. And the first signal, input signal, this tau, and this is x of tau e raised to minus tau. Now fold any one signal. Now if we fold the first signal, this signal h of t, then we are getting the folding of the signal is like this. This is h of minus tau that is on this side, and this is tau, and this signal is as it is tau. This is x of tau, and this exponential signal. Then we will shift this signal, right? Shifting of the signal. Now shifting of the signal along this tau axis, and this signal will shift like this. Here this t here or here like this, means t is changing, means this one is t, and this is h of t minus tau, and now this becomes e raised to minus 2 t minus tau, because here now this becomes t minus tau because we are shifting this, and this signal is x of tau. Now next is take the product of these two. Now as the signal is exist at from t tau equal to 0, right? Before this product is 0, for this period product is 0, and this will start from 0, and the integration, if we are shifting the signal toward this side, right side, then the t value will be changing, means a value, lower limit is 0 and upper limit is t, and from this we will write this as 0 yt, that equal to 0 to t e raised to minus tau e raised to minus 2 t e raised to, means this becomes, we will write first, this is e raised to minus tau, and the second signal is e raised to minus 2 t minus tau d tau. See here, this one is e raised to minus tau, and this is e raised to minus 2 t minus tau. Take the product of these two, d tau, and this over the integration limit is from 0 to this, because this signal will be like this, and this will start from this 0, means this will be in, this will intersect only during this period. This is intersection. Hence we will take the integration from 0 to t. We will rewrite this as 0 to t e raised to minus tau, e raised to minus 2t, and this is e raised to 2 tau d tau. Now this integration is with respect to tau, and this e raised to minus 2t is constant, and we will take this outside the integration. This is 0 to t, this is e raised to 2 tau, and this is e raised to minus tau, means this is e raised to 2 tau minus tau, means we are getting this is e raised to tau d tau. Then integrate this, and after integrating this and substituting this limit, this is e raised to minus 2t, e raised to tau divided by 1, 0 to t, this is e raised to minus 2t into e raised to t, then minus e raised to 0, lower limit. This comes out e raised to minus 2t into e raised to t minus e raised to minus 2t. This is e raised to minus 2t into e raised to t. This become e raised to minus t minus e raised to minus 2t. Means y of t that equal to e raised to minus t minus e raised to minus 2t for t is greater than or equal to 0. And if we plot the graph, then we are getting this graph y of t graph is like this. This will start from the 0 and this. Then computation of the convolution integral with unit step to rectangular. Now here x of t is the unit step function and h of t is the rectangular function, that is rectangular of t divided by w. Then we will draw the first function and dummy variable, that is x of tau. This is u of t, u of tau. And the second one is if the width is w, means this will start from minus w by 2 to plus w by 2, and we will represent on this dummy variable axis, and this equal to h of tau, h of this, and this is the rectangular function. Again the magnitude of both function is 1. Here this is 1, this is 1. Then we will shift this function, right? First fold this function. The folding of this function is same. Folding of this function this is h of minus tau. Then we will take the product of these two. When we will take the product of the first, we have to shift this function. Now we will shift this function by this t, right? If this is t minus w by 2, and here this t plus w by 2. Now here we are getting the different condition. When this is the less than 0, the if t is less than 0, means when this t is less than minus w by 2, that time there is no overlapping. This will occur here, this function, and this is start from the 0. Hence what is y of t? That time y of t becomes 0. Then for w by 2 to plus w by 2. Now in this case, this will start, product will be this function, this is start from 0 and this is t minus w by 2 t, this t minus w by 2 and this is t plus w by 2. If you take the product of these two, then this will start from 0 to t plus w by t. Overlapping area will be from this, means lower limit will 0 and upper limit will be t plus w by t. Hence we will write this y of t that equal to 0 to t plus w by 2 into 1 into 1 into d tau, because the magnitude is 1. And after solving this, we are getting this is t plus w by 2. Then when this is t is greater than w by 2, that time this is greater than w by t, that time this waveform will be like this. Here this, and this will be here. This is t minus w by 2 and this t plus w by 2. Means there is complete overlapping. From this lower limit is t minus w by 2 and upper limit is t plus w by 2. Hence we will write this is y of t that equal to t minus w by 2 to t plus w by 2 into 1 d tau. Then substitute the upper limit t plus w by 2 minus t, and this minus minus become plus w by 2. This will cancel out and this answer will be w. Means we can say that when we convolve this this pulse, that is unit step function, into rectangular function, and for this problem yt equal to this convolution is 0 when t is less than or equal to minus w by 2, as there is no overlapping. Then when this is minus w by 2 to plus w by t, the overlapping will start from 0 to plus w by 2, and we are getting this convolution during this interval. And the last one is when t is greater than minus w by 2, that time the overlapping will be from t minus w by 2 to t plus w by t. This is lower limit, this is upper limit, and by solving this we are getting this equal to w. This is the convolution of this unit step to rectangular. Then computation of the convolution integral rectangular to rectangular only. Now here we will consider these two rectangular pulses. Now first we start. First is start from 0 to 2 and second we start from 0 to 3. Now first we will draw this waveform on dummy variable axis, that is tau. This is the first step. This is 0, 1, 2. This is exist only from 0 to 2. This is x of tau. Similarly, this is 0, 1, 2, 3. This is h of tau. Then fold one signal. If we fold this, then the folding of the signal is h of minus tau, and this is 3, 2, 1, 0. Then shift this signal. We will shift this signal along this, by that this unit tau tau by t, and here this is 3. Now we will find out this overlapping period for this. First one is for t is less than 0. For t is less than 0, right? There is no overlapping of this signal with this signal because this is start from t equal to 0. Hence the yt convolution of these two signal is 0. Then between this interval 0 to 2, this will this is 2, right? This is 2 means we will shift this up to 2, means this will start from 0 to t. Hence we will write this y of t that equal to 0 to t 1 dt, and that equal to t. This is for second interval. Then for third interval 2 to 3, for 2 to 3 this will overlap, right? If we shift this by 3, but this will overlap up to 2. Hence this lower limit becomes 0 and upper limit becomes 2, means between 2 to 3 y of t that equal to 0 to 2 1 into d tau plus 2 to 3, this is 0 dt d tau. Hence the answer for this is 2. Then in the interval, third one is when t is greater than or equal to 3 and less than or equal to 5, that time the limit of this becomes yt equal to, this becomes t minus 3 to 2 d tau. And after solving this, we are getting this is 2 t minus 3, means this comes 5 minus t. Right? Now here we will shift this waveform. By shifting this waveform, we will find out the upper limit and lower limit, and the magnitude is 1. And for last, when t is greater than 5, that time what happen? This is this waveform greater than 5. This is 3 1 2 3 4 5. There is no overlapping with these two. Hence this answer for this one is 0. Y of t that equal to 0, means we will write here the convolution of these two signal, that is rectangular to rectangular, this y of t that equal to 0, right? Then this equal to, when we are getting this one is 0, when t is less than 0, when t is less than 0, then because the first signal is exist from the t equal to t is greater than or equal to 0, hence before that this product will be 0. Then t 1 to 2, between 1 to 2, this is t. Then 5 minus t, this is between, for 3 is greater than, this t is greater than or equal to 3 and less than 5, and this equal to 0, right? 0 for t is greater than 0. It happen this 5 minus t, right? And again we are getting this is 0 for t is greater than 5. And if we plot this graph here, yt versus this t, this is 1 2 3 4 5, then this is 1 2 3 4 5. Then we can say that between 1 to 2 this is t, means this is the ramp function having the slope 1. Between 2 to 3, right, this is constant. Between 2 to 3 हे आपण लिहिलं नाही, दिस इज कॉन्स्टंट 2. काढलं काय आपण 2 बघू. हा, दिस इज बिटवीन 2 to 3, दिस इज 2, दिस इज कॉन्स्टंट. देन between 3 to 5 this is 5 minus t, and at t equal to 5 this becomes 0, like this. For 3 this 5 minus 2 this is 2, then as this is in this, for this is 1, like this, and this is the y of t. Now in this lecture we discuss the convolution integral for the continuous time signal, and using graphical method we studied the convolution of the step function with the step function, then unit step function with the exponential function, then the exponential function with the exponential function. Then we discuss the convolution of the unit step to the rectangular function, and last one is rectangular to rectangular function. Thank you. We will stop here.